So, Bismillahirrahmanirrahim. Our today's topic is effective or RMS value, right? Effective or RMS value. So, RMS stands for root mean square value. Uh, that is root mean square. So, the effective or RMS value of periodic current is the equivalent value of DC current that delivers the same amount of average power to a resistor as the periodic current. So let me write it down here. The effective or RMS value of a periodic current is the equivalent value of DC current that delivers the same amount of average power to a resistor as the periodic current, right? So the formula for the RMS value is given by, for example, I subscript RMS is equal to 1 over T to T. So I square dt. So this is a square, and then this is the mean, and this is the square root, right? So root and then mean of this square value. So that's why it is called root mean square value. Similarly, this signal can be replaced by a voltage signal, and we can calculate the VRMS value here. Okay, so naturally a question arises: why don't we use the simple average value of a current? Simple average value. Why don't we use simple average value? Why not use average value, right? So if you consider sinusoidal signal, for example, then the average value is 0, right? This sinusoidal signal, the average value is 0. So that's why we do not use the average value here. And one more thing, if there is a resistor R, as we are talking about a resistor here, so average, the instantaneous power is given a P is equal to I square R, right? And then the average can be calculated over one period. For example, the average power in this case is given by, for example, 1 over T and I square R dt and 0 to T, right? So that can be written as P is equal to 1 over T, and this is 0 to T I square dt, and R can be multiplied here, right? Multiplied by R. So this is the power. We replace this term here with the effective square of the effective value. So this term is, for example, IRMS. So I square RMS basically, right? R multiplied by, so that will be then R multiplied by I RMS square. So if we compare both these sides of this equation, then I square RMS is equal to this value, 1 over T, 0 to T, I square dt. And then naturally, IRMS is given by 1 over T, 0 to T, I square dt, and square root here. So this is this formula, the same formula here. So this is the formula that we use to evaluate the RMS value or the effective value of current. Uh, the usually used voltage and current is usually sinusoidal, and we can put in the value of I of t is equal to Im cos omega t here, and then find out the RMS value of a sinusoidal current is given by Im divided by square root of 2, and Vrms is given by Im is the peak value, right? And Vm is the peak value divided by under root 2. This is the peak value here. This is Im, right? So for a sinusoidal voltage or current, whether it's in sine form, whether it's a function of cosine, the RMS value of a sinusoidal function is given by this formula. So if you are given a voltage or current in a sinusoidal form, you can easily use this formula to find out the RMS value of the current or the voltage. However, if the signal is not in sinusoidal form, is a sawtooth, for example, is a square wave or in any other shape, then you need to use this basic formula here, the basic principle here, to find the RMS value or the effective value of that signal, right? So, for example, if this sinusoidal signal has a peak value of 16, right, then this RMS value of this signal will be 16 divided by square root of 2. Right? But if this is another shape, it's not sinusoidal, then it is not 16 over 2. Then you need to find out the average or effective value using this formula here. So let's try out an example, a problem here. For example, so find the RMS value of the current waveform of fig 1. This is fig 1 here. If the current flows through a 9 ohm resistor, calculate the average power absorbed by the resistor. So as I have told you here, we can calculate the average power in two ways. So I square multiplied by R and then find the average like this, right? Or we can first find the effective value, RMS value of the current, and then multiplied by R to find the average power. Okay. So this is the wave shape given here. This is not sinusoidal, so we cannot use I square RMS over 2. We need to use this formula here. P is equal to I, right? I RMS. We need to first find the RMS value of the current. I RMS is equal to 1 over T and 0 to T I square dt and the square root. RMS is obviously given by 1 over T 0 to T I square dt here. So for us to be able to use this formula, we first need to find the equations for the at least one period, right? We need to integrate this over one period. So the period of this waveform is equal to 2, right? It repeats this pattern over after 2. So period is 2 seconds, right? And this triangular shape consists of two lines from 0 to 1. T is equal to 0 to T is equal to 1, it's this line, and then T is equal to 1 to T is equal to 2, it is this line, right? So the equation of a line can be found in many ways. For example, we can use two formulas. Y is equal to mx plus c, right? X is along the horizontal axis and y is along the vertical axis. Or we can use y minus y1, right? And over y2 minus y1 is equal to x minus x1 over x2 minus x1. So x is along the horizontal axis and y is along the vertical axis. And here in our given problem, the horizontal axis is t, right? And the vertical axis is I. So x is equal to t here, or t is equal to x here, and I is equal to y here. in this above formula. So for our case, this becomes, this formula becomes I minus I1 divided by I2 minus I1 is equal to T minus T1 divided by T2 minus T1. So we are first interested to find the equation for this line here for the interval t is equal greater than 0 to t less than 1. So to find this equation, we call this as the first point. This is, for example, T1 and I1. As for us, this is T1 and I1. And let's call this point as T2 and I2 corresponding to x2 comma y2, right? So at this point, T1 comma I1, T1 is a 0 here and I1 is also 0 here. And at this point, T2 comma I2, T2 is, the value of T2 is 1, right? And the value of I2 is 4 here, right? So this is 4 here, I2, and T2 is 1 here. So let's substitute these values here in this formula. So I is I minus, so I1 is 0 divided by I2, I2 is 4 minus I1 is 0, and that is equal to T minus T1. So T1 is 0 divided by T2, T2 is 1 minus T1, and T1 is again 0. So that is I over 4 is equal to T over 1, that is T. So I is equal to 4T. Over this interval, T is greater than or equal to 0, T is less than or equal to 1, I is equal to 4T, right? Now let's find the equation for this other segment, other line, this line segment, for T greater than 1 and less than 2. Here, now the roles, we need to change the roles. We call now this as T1 comma I1, right? And we call this point as T2 comma I2 corresponding to x2 comma y2. This corresponds to x1 y1 now in this formula, and this corresponds to x2 y2 x2 comma y2 in this formula here. So again, we need to substitute these values of T1 I1 and T2 I2 in this formula here. So I minus, let's find out the values first. So T1 comma I1. Now for this case, T1 is 1 here and I1 is 4 here. At this point here, T1 is 1, right? At this point T1 is 1 and I1 is 4. And at this point T2 comma I2, T2 is 2 here and I2 is 0 here, right? So I2 is 0. So we can now substitute these values in this formula. So I minus I1, I1 is 4 divided by I2, so I2 is 0 and minus I1, that is 4, and that is equal to T minus T1. So T1 is 1, T1 is 1, and divided by T2 minus T1. So T1 is T2 is 2 minus T1, and T1 is 1. So this becomes I minus 4 divided by minus 4 is equal to T minus 1 over 1. So that is basically T minus 1. So this becomes I minus 4 is equal to minus 4 into T minus 1, right? So that is I is equal to minus 4T and plus 4, and then plus 4, this 4 here, right? The plus 4. So I of t is equal to minus 4t plus 8, or in other words, I of t is equal to, we can take out 4, this is minus t and plus 2, and this is for this interval t greater t from 1 to 2. So I of t is given by this equation. I of t is equal to 4t, and when t is greater than 0 less than 1, this interval, right? And I of t is given by this 4 into minus t plus 2 when t is greater than 1 and less than 2. So this is the complete equation for I of t for this one period that we have found. So using this equation for one period, we can find the RMS value. We need to substitute this value here in this formula to find the RMS value of the current. So for example, I square RMS. So I square RMS is equal to 1 over t 0 to t I square dt. So I square RMS is equal to, and t here is 2, right? We have found that t was 2. So t is equal to 2. So 1 over 2, and the period is 0 to 2, but we know that we divide this period into two segments from 0 to 1. From 0 to 1, I is equal to 4t, right? So 0 to 1, this is 4t square dt, and plus 1 over 2, then 1 to 2, this is 4 into minus t plus 2 square dt, right? This 4 into minus t plus 2, right, from 1 to 2. So 4 into minus t plus 2 squared, and this dt here, right, from 1 to 2. So I square RMS is equal to, this is a 4 square is a 16, that is 16 over 2, and this becomes t cube over 3 when integrated, and the limits are from 0 to 1. Then again this is a 16 over 2, 4 squared is 16 over 2, and we need to open this square. So this is t square plus 4, and then minus 4t, right? And dt here we're integrating with respect to t. So I square RMS is equal to 8, and 1 over 3 minus 0, right, plus 8, and we need to integrate this now. So this will be t cube over 3 plus 4t minus 4 over 2 t square, that is minus 2 t square, and the limits are 1 to 2. So I square RMS is equal to 8 over 3 and plus 8. This is t cube over 3, so that means 8 over 3. 8 over 3 plus 4 into 2, 8, and that will be minus 2 square 4 into 2, 8, and then minus 1 over, putting the lower limit now, 1 over 3, right, plus 40 so sorry 4 multiplied by 1, right, 4 1, that is 4, 1 over 3 plus 4, and then this is minus 2. So I square RMS is equal to 8 over 3 plus 8 into 8 over 3. This cancels, this cancels. This is minus 1 over 3, and there's 4 minus 2 is plus 2, and this is minus 2 here, right? So I square RMS is equal to 8 over 3 plus 8. 8 over 3 minus 1 over 3, that is 7 over 3, and minus 2, and 8 over 3 plus 8, and 7 over 3 minus 2 over minus 2, so that is 6 over 3, right? So that is 1 over 3 again, 1 over 3. So I square RMS is equal to 8 over 3 plus 8 over 3, that is 16 over 3, right? And we can find this value. 16 over 3, 16 divided by 3 is given by 5.33, and the square root gives 16 over 3 square root, that is 4 over under root 3, right? So so that is 2.309 amperes. So IRMS is equal to 2.309 amperes. So this is the effective value or RMS value that we have found. We were supposed to find the power also. So the power to a resistor is given by IRMS square divided by multiplied by R. So the RMS value is this, and the square is this. So 5.33. What was the value of the resistor? The value of the resistor was 9 ohm resistor. So 9 multiplied by 9, right? So P is equal to 5.33 multiplied by 9. So that is 47.97 or 48 watts. The power absorbed by the resistor is 40 watt. So this was about this problem. Also note that we found out that the average power is given by the 1 by 2 Vm Im cos theta V minus theta V, right? So now we have found that for a sinusoidal source, V RMS is equal to Vm over under root 2. That is, Vm is equal to square root of 2 multiplied by Vrms. Similarly, Im is equal to square root of 2 Irms, right? So substituting these values of Vm and Im over here, so this will be 1 over 2 multiplied by square root of 2 Vrms multiplied by square root of 2 Irms cos of theta V minus theta I, which is the angle of the impedance. So this under root 2 multiplied by square root of 2, this cancels out with this. So P is basically is equal to Vrms multiplied by RMS is equal to multiplied by cos theta V minus theta I, right? And also using the peak values, the average power is given by this. If you're using a sinusoidal source, so then the average value is given by 1 over 2 Vm Im cos theta V minus theta I. And this can also be expressed in terms of the RMS and effective values as this. Similarly, the average power absorbed by a resistor. So the average power power absorbed by a resistor is given by equal to 1 by 2 the square of the absolute value of I multiplied by R. This was the peak value, right? So again, this peak value is equal to square root of 2 RMS value, right? So substituting this value here under root 2, that is 1 by 2 square root 2 IRMS square R. So that is IRMS square R, right? And similarly, P was equal to 1 by 2 V, the square of the peak value multiplied by R, over R divided by divided by R. So if we put Vm is equal to under root 2 RMS, so that would be P is equal to V RMS square divided by R, right? So this concludes this discussion here.